This next lecture is really not necessary unless you're really interested in the workings of the two types of formula. So what I'm going to do this on is the finished bike racing times here, for finish times for a bike race, and these are all in minutes. And I've taken this data and I've ordered it. So you see ordered data over here: 21, 22, 23, 24, 26, 28, 33, and 37. Those are the 1, 2, 3, 4, 5, 6, 7, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So what we know is that our n is equal to 8. So I'm just going to write that down right now. Now, all of these we're going to have to add up. So we're going to have to find the sum. We're going to use our calculator to do that. So I would like you to pause your video right now, and I'd like you to enter the bike times into your calculator. Entered these all in, checked them and double checked them, and then you can use your one variable statistics to add them all up. And what we've got here is 214. Now, what we'd like to do is we'd actually like to get an idea behind what's going to go on with the computational versus the defining formula. So I want us to actually practice what this means. So this means that we're going to square this value here, and we're going to square this value here. Now we can actually accomplish this using our calculator, or we can do it by hand. To do it by hand, it takes a lot of time. So to do it with your calculator might be the easier thing to do. And what I would like us to do is to actually use the calculator register. So you're going to go into your next register over. Let's say L1 is where the X's are, so into L2 register, and you're going to go up into where this actually is. And then you're going to do L1, and you know how to get the L1 in there, right? Second function number 1, and then you're going to hit your square key. And that is going to make your L1 look squared. And then you'll hit the enter key, and your whole register should fill with these values squared. And you can actually check it out by doing 21 squared and seeing that you get the same value. So why don't you take a moment and see if you can. Okay, if you were successful, this is what you should have gotten. You should have gotten 441 for 21 squared, and you should have checked that to see. And for 422 squared, you should have gotten 484, and so on and so forth. And in a second, you'll see these magically appear. Okay, so now the next thing that we want to do is we want to add all these values up. That's our sum of our x squared values. So you can actually go through and physically add these up, or you could let your calculator do it for you. And this time, if this is in register 2, you go calculate one variable statistics on register 2. And this time you're looking at your sum of the x's, not sum of x squareds, because your calculator has the values of x squared as its x values. So you look at the value sum of the x's, and it says that this sum is 5, 9, 4, 8. Now if you go back to your original information on those one variable statistic, or the one variable statistics on your original information, then you'll see that that is indeed what your sum of your x squares are going to look like on that second or on that data register. So if we do that, we see that the sum of the x squareds for the original data for the 21 through 37 is indeed 5948. So I want you to just be able to see what these look like. Now the next one that we're going to do, so let's first of all put that this was the sum of the x squareds. The next thing that we're going to do is we're going to do the x values, and we're going to subtract the mean from those. So in order to do that, we're going to have to compute our mean first. And so we're just going to review computing our mean. Our x bar, remember, is our sum of our x's, which is 214, and then divided by 8. And so x bar, 214, divided by 8 is 26.75, and I'm going to use that actual value, 26.75, because remember, that is the most accurate. Now this one, with bike race times in minutes, I'd round it to report it to 26.8, but I actually want to use 26.75 in here. Now I can use my data registers to do this as well, and what I'm going to be doing is 21 minus 26.75, and then here I'll be doing 22 minus 26.75. Now I could do this by hand, or I can let my data registers do it. Go into L3 and then up into L3, right, where this would be L3, and then I would say L sub 1 minus 26.75, and then I can get those values. So go ahead and find those values, whether you're using your data register or not, you decide. And what you should see is that for your first one, you got a negative. It is important to report a negative. Order does matter here. Negative 5.75. For the second one, you also got a negative, and this one is a 4.75. For the next one, you got a negative 3.75, and then a negative 2.75, and so on and so forth. And you're going to see these magically appear in a. Okay, so here are all of our values here. Now you could add them up, but it's not going to do you very much good, because guess what the deviations about the mean are? 0 when you sum them up, and that's why we square them. So we're going to go ahead and square them. So what you're going to do in this next column, you're going to take the value in the third column here, negative 5.75, and you're going to square that value. And then you're going to square this value and this value and this value and so on and so forth. And you can again do that in your data registers. You could go into register, what would it be? This is 1, 2, 3, and 4, so up into L4, and you could do second function, L sub 3, and then squared. And then hit enter, and it'll fill your register with all the squares of these values. So you could do that, or you could go through and square these by hand. It's totally up to you. I'm going to let you do that on your own, and when you unpause this, then you're going to see the whole thing filled. Okay, so if you squared negative 5.75, you get 33.063, and then this is the rest of them. Now, once we have these, what we want to do is add them up, because those will be the sum of the x minus x barred squares. So if you've got this in your data register number 4, you can just do the one variable statistics on it and find the sum of the x's, because these are your x values. Sum of your x's will actually be giving you your sum of your x squared values in this particular case. So I'm going to go ahead and do exactly what I said I was going to do, find those one variable statistics based upon those, and the value that I get for this is 223.5. So 223.5. And now, finally, we're ready to calculate this variance of this sample based upon that defining formula. So based upon the defining formula, S squared looks like the sum of the x minus x squared, or x bar, values squared, divided by n minus 1. So our value, 223.5, divided by, and our n was 8, and so we have 7 down here, is going to be equal to, so let me do that, 223.5 divided by 8, which is equal to, oops, not divided by 8, sorry, 223.5 divided by 7 is equal to 31 point, and that would be 928.571, or approximately 31.9, and these would be in minutes squared. So all of that work right here is what you would have to show in order to use the defining formula to find your variance. Now here, in contrast, is using the computational formula. To use the computational formula, you simply put just the bike times into your calculator right here, and then you used one variable statistics, and you were allowed to come up with this number here from one variable statistics, no work necessary in order to do that, and you put them in. So n, which is 8, times the 5948, which came from your one variable statistics on the original data, times the sum of the x's, which was 214, and that value squared, and then times n times n minus 1, which is that, and the only values that you have to put in are going to be 8 times 5948 and 214 squared, and then the difference of those, so 8 times 48, and that gives me 47584, and then minus 214 squared, so that's 45796, and 4784 minus that 47584 minus 45796 is equal to 1788, and that is going to get divided by 56, and that divided by 56 is equal to exactly what we got up here. So this is exactly 31 31.928571, and then it continues on from that, but that's all I need, which is 31.9 squared minutes. And you see the formula, even though it looks totally different, gives us exactly the same answers as it did before. So the easier formula to actually use is this second one. It looks really complicated, but in order to show the work for this one, which I do require in my class, you have to do a lot of work. And even just to do the formula is a lot of work because you have to do all of those steps that I have just shown you. So which would you prefer? This whole table, even with a calculator, is still quite a bit of work, or just entering your data points and then letting one variable statistics tell you the sum of the x squareds, the sum of the x's, which you'll square, multiplication here, squaring here, difference here, product in the denominator, quotient to find your answer. Much easier, huh? And so that is how to see the difference between defining and computational. And please, please, please use the computational formula. I don't want you using the defining formula. And it's just crazy to use that defining formula. Now, here in my notes, you'll actually see the population variance, and here's an example with population done. I'm not going to bother doing that one even for our video notes here. So the next video that comes up, we'll be talking about doing a frequency table and or using a frequency table in order to do our variance.